Welcome, my dear students, to another week of chemistry with Mr. Miguel. This week, we will be covering the changes in the states of matter. This means, how does it change from solid to liquid to gas? The objectives for the week are the following, so let us delve right into objective number 1. Before actually embarking in this journey, in discovering what causes the changes of matter, let us ask that basic question. What exactly causes the changes in the states of matter? What makes things go from solid to liquid to gas? The answer is very simple: energy. As you add energy to particles, the particles vibrate faster and faster and faster and faster until they change their appearance, how they change the state of matter. So my question to you is this: what would happen if we remove the energy from these particles? That is something to think about. So we know that energy content, how much energy a particle has, actually decides the state in which the particle can be found. And the more energy, we know that the more vibrations of particle and the faster the change. So these are the changes. This is a summary of what we will cover today. We need to identify the changes in the states of matter. In this picture, in this slide, you will find that we have solid, liquid, and gas, the three states of matter that we are concerned with. Whenever a solid, let's say ice is solid water, it's still water, starts to become watery. When ice starts to become watery, we know that it is melting. The process in which a solid becomes a liquid is known as melting, and it turns into liquid water, which we commonly refer to as simply just water. So melting is the change from solid to liquid. When you start heating something too much, a liquid too much, it eventually evaporates, it goes into the atmosphere, and we call that evaporation. If something is changed directly from solid to a gas, we know it as sublimation. We will talk about all of these changes in more detail in the next few slides. So objective number 2 is to explain how energy affect changes in the states of matter. Let us have and look very closely at the first change in state of matter. This is known as melting, and it is the change of a solid into a liquid. And in this case, I have in my picture, I have butter. And butter, if you know from experience in the kitchen, once you add it to the frying pan and the frying pan is hot, it will start to melt. Why exactly does it start to melt? Well, you see, the butter is made out of particles, and those particles are usually vibrating, so we know that they are moving, but with the heat added, they start to vibrate much harder than they start to collide against each other and bounce out against each other. Then they form something that we know as a liquid. So butter melting is a perfect example of how solids butter melting is an example of how solids can easily enter the liquid phase with the addition of energy. Our next state of matter is evaporation, which is the change from liquid into a gas. How does this happen? This happens because the energy, so we know that in liquids, particles already have enough energy, but as they get heated and you add more heat, you are giving these particles much more energy to collide against each other. So they hit against each other harder. And the harder that they hit each other, they bounce faster and with much force, with more force. And as this happens, particles start overcoming the forces of attraction. That means we know from the particulate theory of matter that particles experience forms of intermolecular attraction. That means that there are forces that keep particles together. So when you add heat, this bond that they had stops existing because they have so much energy, they're free to fly off. And this is what happens in evaporation, which is the process in which the liquid turns into a gas. There are cases in which a solid can go directly from being a solid to a gas. This process is known as sublimation. Just to clarify something, from the start, in this solid, all the particles, they don't like each other. They actually hate each other. And they just need a tiny bit of energy in order for them to just fly off. And the process in which a solid turns directly into a gas, we know it as sublimation. And it is quite easy to understand. A while ago, I asked a question. What if you take away the energy from particles? What happens then? And here is the answer to that question. Let us look at this change in the state of matter. Freezing. In freezing, we know that a liquid is being turned into a solid. In this image, you're able to see the glaciers in the North Pole. And this glacier is made out of huge chunks of ice. How did this happen? Well, we know that the sun cannot directly hit the poles. That means it hits directly on the equator. So because the poles are normally facing away from the sun, they don't get the energy. And because they are constantly losing that energy, you know that particles, they always want to move, but sometimes whenever they start losing the energy, they start coming together. And when they come together, they form like little magnets at an atomic level, and they join to each other. Because they're losing the energy, they are coming together. And when they do this, it is known as freezing. Freezing is the process in which liquids turn into a solid. Our next process, a little bit harder to understand, is condensation. Condensation is the process in which a gas turns into a liquid. And there are a few instances in which you have experienced condensation. To condense means to come together. So we have particles of water flying off in the atmosphere, and when they come together and they start joining with each other, they form water droplets that we know as dew. Early in the morning, you can see on the grass little drops of water forming, as you can see on the picture. The process by which this happened is known as condensation. It also happens in the clouds. After evaporation takes place, the water reaches the clouds, and up in the clouds, the particles, they had a lot of energy, but then they start losing that energy and coming together. That means to condense. When they come to each other, that's condensation. And that is an important process in which gas turns into a liquid. Now, there are cases in which a gas can directly form a solid. and this is known as deposition. From the word deposit, that means that the gases deposit directly, but because they lost the energy way too quickly, they formed a solid. And this is usually evident on glasses in North America and South America during winter. And during winter, you should be able to see that it wasn't snowing, it wasn't raining, and all of a sudden there's frost covering the glass. That is known as deposition, the process in which a gas directly turns into a solid. That was it for how energy level affects the changes in the states of matter. Our next objective is to look at heating and cooling curves. My dear students, as you are able to see in this slide, this is a heating curve. Anytime we plot a graph, we normally refer to it as a curve. And in this case, we call it a heating curve because we're adding heat, okay? It means that in this curve, we're able to see how matter changes as we add heat. That's what it means. How do we know that matter is changing? Well, here we start with a solid, and we ended up with a gas. And we're able to see the changes in the states of matter from this curve. Here, the process in which a liquid becomes a solid is known as, you guessed it, right, melting. The process in which a gas turns into a liquid, you guessed it again, it's known as evaporation. And here we can see the states of matter, liquid, solid, and gas. But most importantly, what we're able to see here is that as we add heat, the temperature increases. Okay? That's what it means. Next thing you need to bear in mind, like for example, during melting, we see that the temperature does not change until everything has melted. In boiling, like here, this is the boiling, we know that unless everything has evaporated, the temperature does not change. That means it will remain at 100 degrees Celsius until everything has evaporated. It will not go to 150, 160, no. This gives us better appreciation for substances because each and every substance have specific boiling and melting points. Okay? So if I gave you the melting point of a substance and the boiling point of that same substance, you should be able to identify that substance among other substances. In this particular one, we have water. It melts at 0 degrees Celsius and it boils at 100 degrees Celsius. Other substances can melt at 20 degrees Celsius and evaporate at 200 degrees Celsius. Like what, mister? What would have such a high melting point? Take, for example, a metal. You would need to add a lot of heat for it to melt. Will it still be the metal? Yes. And it would take even more vast quantities to evaporate. Yes, that happens. That's a heating curve. In this other curve, it's just the inverse or the opposite. We see that in a cooling curve, it's known as a cooling curve. A curve is a plotted graph. So anytime you do a line in a graph, it's normally referred to as a curve. Well, it's not a line, but once you plot your points, you can refer to it as a curve. And in the cooling curve, it's known as cooling because we're taking away the energy. And in this scenario here, again, we have water turning from gas to a liquid. The process here, what is happening here? You guessed it right. Condensation. And here, what's happening? Freezing. In this case, we are just taking away the energy from particles. That's as easy as it gets. Moving on to our last objective, we want to utilize the explanation of the changes in the states of matter to explain the hydrologic cycle. I want to share something with you. As I am recording this video, it is raining quite hard outside. That is known as precipitation, and that's water droplets in the form of liquid falling from the sky. But this happens in a cycle. It means it's never ending. So let us see how the changes in the states of matter can be easily observed in this diagram. So here we see that the sun is that yellow structure. It sends energy into the oceans, into the rivers, into lakes, into human beings, and that energy causes the water particles to vibrate faster. As they vibrate faster, they rise into the atmosphere until they reach a certain altitude, and at that altitude, the energies in the particles would have decreased. They come together, they condense. So they condense. Wind probably takes it into the mountains. It continues condensation all along, and when it falls to the ground, it is known as precipitation. And the process happens over and over and over. Sometimes when the temperature is too high in the mountain, it becomes ice. That means that the water, the liquid water, has lost all the heat that it contained, and that's the water cycle, also known as the hydrologic cycle. And that is all for this week. Thank you very much for your keen attention. Have a blessed rest of the day.